everyone, so I am back with the third video of the video series on data handling class 8 maths, and in this video our agenda is to understand in the best possible way the grouped frequency table. Now this is a very important concept and a lot of children find it confusing, but not after watching this video. So are we all ready to get started? So I am Roshni from LearnerHub, the free learning platform where you get to study maths and science absolutely for free at learnerhub.com. So what are we waiting for? Let's get started. So now that we have understood grouped frequency distribution table, let us try to make a grouped frequency distribution table. So data on weights of 20 students of a class are given. So use class intervals 30 to 35, 35 to 40 and so on to make a grouped frequency distribution table. Now looking at the class intervals which are given, can you tell me whether it is exclusive or inclusive? So what kind of class intervals are given? The class intervals are something like this: 30 to 35, 35 to 40, 40 to 45, 45 to 50 and so on. Now how am I able to write all the class intervals? That's because two class intervals are given. So basically with this I got to know the size of the class interval. What is the size of the class interval? Size is upper limit minus lower limit, that is 5. So every class interval should have a size of 5. And looking at these two, we found that the upper limit of the first class interval is the lower limit of the second class interval. So with that we understood that the upper limit of the second class interval should be the lower limit of the third class interval and so on. So knowing this, we can actually create all the class intervals. Right? So now since the upper limit of first is the lower limit of the second class interval, this shows that this is an exclusive class interval. This is an example of exclusive class interval, right? So these are certain things that we learned some time back. So it is kind of revision for you. Now till where will I keep making these class intervals? Now for that we should know what is the maximum data that we have, what is the maximum entry that we have here. Now when you look at this data, so the maximum data, the maximum number that we have here is 65. So there is nothing which is greater than 65. So I think we will have to create these intervals till the time we cover 65. So do you think that we have included 65 by now? No, because in this interval again it is an exclusive interval. So 65 is not included in this class interval. So we need to create another class interval. So now we have created all the class intervals that are needed to cover this set of data. Right? So these are our groups. So we have created one column of frequency distribution table. Now what would be the next column? The next column would be for tally marks. And the third column would be for frequency. So that's how we create frequency grouped distribution table. Now for the group 30 to 35. So let us quickly have a look. So 30 to 35 we have 33, we have 31, we also have... Do we have something else? We have 34. So we basically have 3 data. So the frequency would be 3. Now 35 to 40. So 35 to 40 we have 38. We also have 36. We have 38. We have 39. So we have 4 data. So the frequency would be 4. Similarly for 40 to 45. Again we have 4 data, so the frequency would be 4. Now in a similar way we can continue to count and then fill this table. So for each of these we just have one data. So now this is how we create a grouped frequency distribution table. Now in order to create this table, the first challenge is to create the class intervals. Now, and how do we create the class intervals? For example, here the sample class intervals were given. The question already mentioned that these are the class intervals that you are supposed to take. So first of all, find out the size of class interval. So once you have found the size, you can maintain the same size of the class interval throughout. Also, looking at the first two class interval, you got to know whether it is exclusive or inclusive, so that you can make the remaining class intervals accordingly. So this is how you make a grouped frequency distribution table. So now that we have discussed about frequency distribution tables, we will now try to make graphs based on these tables. So it is going to be a combination of the graphs and grouped frequency distribution. So in this section, what we will learn is how can we make graphs looking at the grouped frequency distribution table. So if we are given this table, like how it is given here, so from this table, how can we draw a graph like this? So that is what we are going to connect in this section. So the first thing that we will discuss is how do we draw bar graphs. Now we have already discussed the different types of graphs like the pie charts, bar graphs, line graphs, etc. So first we will start with bar graphs. So how do we draw bar graphs? So what is given on the screen? All that you see on the screen is a grouped frequency distribution table, because you have groups here in the first column. It is just that the tally marks column has been removed for now. So you have your class intervals or the groups and their respective frequency. So how would you draw a bar graph? Now whenever you look at a bar graph, it looks somewhat like this. So bar graphs, they consist of bars which are nothing but rectangular pieces. Now when you look at any of the bars, so each of these rectangular pieces is called a bar. Now the width and the height of the bar tells us a lot of information about this grouped frequency distribution table. That's because the width of the bar graph, this is the width of the bar graph, and this width of the bar graph tells us the size of the class interval. So in this case, what is the size of the class interval? So here, if you find out the size of the class interval, it would be 40 minus 20, which is equal to 20. Now, when you look at these graphs, the width of these graphs would be 20. So, width of each of these graphs would be 20. So, the width of the bars tell us the size of the class interval. Now, what about the height? Now, when you look at the height of each of the bars, the height tells us the frequency. For example, the last bar is for the class interval 80 to 100. So for 80 to 100, what is the frequency? Frequency is 5. So the height of the bar is till 5. So the height of this bar tells us the frequency, which is 5. So basically the concept is that once you have this table, the grouped frequency distribution table, first of all look at the class intervals, plot the class intervals on the x-axis, and then make sure that whenever you draw a bar, the width of the bar should be equal to the size of the class interval, like how we have drawn it here. So when you draw the first bar is for class interval 20 to 40. So that is why you have chosen these 2 points, 20 and 40, so that the width remains 20. And then how much would be the height? The height is determined by the frequency. So the height is at 1. So basically you draw these lines and then you draw a bar, because a bar is nothing but a rectangle. So the length and breadth of the rectangle are determined by the size of the class interval and the frequency respectively. So now once you know the height of the bar and the width of the bar, it is very easy to draw a bar, and you draw one bar for each of the data, each of the class interval. You draw one bar. So this is how you end up having a bar graph. Now another interesting thing is, like when you look at this table, you see that it starts from 20. So it starts from 20 to 40, then 40 to 60, 60 to 80, 80 to 100. Now what happens after 100, we do not know. And what happens before 20, that also we do not know. Right? Now whenever we have a table where the class interval doesn't start from 0. Now it might start from 20, it might start from 40, it might even start from 100. Now in this case it was 20. So that is why what we have done is we have kept 10 here, but we started it from 20. Now let's say that if you have a table where it starts from maybe 500. So in that case, do you think that you will leave this much of area of the graph paper blank and then start from 500? No, you will not do like that. In that case, what you will do is we use a jagged line to show that there is no data which is present for that range. For example, here till 20. We do not know. There is no data that is given for 0 to 20. So what we do? We make use of a jagged line, a curved line like this. So when you have a curved line like this, the line here is not straight, which says that we have absolutely no idea about the data from 0 to 20 because that is not given in the problem. So in a similar way, even if you have a class interval like 500 to 520, then 520 to 540, 540 to 560 and so on, in that case also you just give a jagged line and then you start from 500. So that will just tell that there is no data available for the range 0 to 500. So that is another important thing. So I think keeping these 3 points in mind, you will be able to draw a bar graph given a grouped frequency distribution table. So the first point is that the width. So the first point is width of the bar is equal to the size of the class interval. Second point is that the height of the bar is equal to the frequency of each class interval, and the third point is that use a jagged line, like in this case 0 to 20 is that area for which there is no data available, so it has been marked with a jagged line. Now another interesting term that is being used for these rectangular bars of the bar graphs are histograms. So what are histograms? These are nothing but the rectangular bars of the bar graph. So when we draw the bar graph, we were drawing the rectangular bars. So those rectangular bars are called histograms. Now the next question is, where exactly do we use histograms? I mean, is it that we can use histograms everywhere? Can we draw bar graphs everywhere for any kind of data? Not really. Histograms are used to represent grouped frequency distribution. Now you might say that why only grouped frequency distribution? So even if I have a normal frequency distribution table, why can't I draw a histogram? Now let us try to see. So let's take an example and we say that we have favorite fruits of the number of students in the class. And this is how the table looks like. So apple is being liked by 5, orange by 3, grapes by 3 and mango by 1. So this is our frequency distribution. Now do you think that we can make a histogram for this data? We have the frequency, but do you think that a histogram can be made? What is a histogram? Histogram is made up of rectangular bars. And in order to draw the rectangular bar, what do you need? You should know the width and the height of the rectangular piece. Now height is nothing but the frequency. So the frequency is given here. So height is fine. But what about the width? For the width, we need to know the size of class interval. And the concept of class interval comes into picture only in case of groups. So that means for this frequency distribution table, we do not have a width of the bars. And since we do not have a width, so histograms are not possible. So we cannot draw bars without any width, right? Therefore, we cannot make histograms in this case. Now, you might say that, but still I want to represent this data graphically. So how do I do? So you might have other options. Maybe you can make use of a line graph. We have discussed about line graphs before, right? So let's see that how we will draw a line graph here. So line graph could be something like this. Let's say this point represents apple, this represents orange, grapes and mango. Now, and here you have 1, 2, 3 and so on. So apple being liked by 5, orange is being liked by 3, grapes is also being liked by 3, mango is being liked by 1. So when you join these points, you get a line graph. So this is a graph that you can draw for this type of a frequency distribution. But the moment you talk about a grouped frequency distribution, something of this sort, where you have groups, where you have class intervals, in this case, you have the class size and you also have the frequency. Therefore, you can draw a bar graph or a histogram like this. And that is why we say that histograms can be used only to represent grouped frequency distribution. So based on whatever we have discussed so far on the bar graphs and the histograms, the frequency distribution table, let us try to answer a few questions. Question number 1. For which of these would you use a histogram to show the data? Now, before we look at the scenarios, let me remind you that a histogram is only used for grouped frequency distribution. So, any type of data which can be divided into groups, only they can be represented using histograms. First scenario, the number of letters for different areas in a postman's bag. Okay, so in a postman's bag, you might have letters that belong to different areas. So do you think that a histogram can be used here? So in this case, your data would be something like this. Let us talk about the first scenario. So if you try to visualize the frequency distribution table that you might have in this case, so that would be something like this. Let's say the areas and number of letters. So maybe for area A, there might be 10 letters. For area B, there might be 5 letters. For area C, there might be 23 letters, and so on. So somewhat the frequency distribution would be somewhat of this kind. So do you feel that this can be divided into groups? No. So there is no grouping in this. You do have frequency, but there is no grouping. So therefore, this cannot be represented by histogram. B. Height of competitors in an athlete's meet. Height of competitors. Now, when you talk about height of athletes, now in an athlete's meet, there will be many athletes, right? Now, some of them might have they all would have different heights, right? Some of them might be 5 feet, some of them might be 6 feet, some might be 7 feet, some might be 6.1. So they all will have different heights. But in this case, what you can do is you can actually create groups. So you can actually create groups in the sense that how many athletes fall in the height range of, say, less than 4 feet. How many of them fall in the range of 4 to 5? How many of them fall in the range of 5 to 6, and so on? And on the other hand, you can write down the number of athletes who are in this height range, right? So in this way, you can actually have a grouped frequency distribution table, and therefore you can use histogram to show the data. C. The number of cassettes produced by 5 companies. Now in this case again, you have the name of the companies and the number of cassettes that are being produced by them. So let's say you have a company X, company Y, company Z, and so on, and the number of cassettes that they have produced. So in this case, do you think that you can create groups? No. So no groups, no grouped frequency, therefore no histograms. The last one, number of passengers boarding trains from 7 a.m. to 7 p.m. at a station. Now this can again be divided into groups because you have a bigger time interval, that is from 7 o'clock in the morning till 7 o'clock in the evening. So here the time can be divided into groups. Maybe passengers from 7 a.m. to 8 a.m., 8 a.m. to 9 a.m., 9 a.m. to 10 a.m. and so on till 6 p.m. to 7 p.m. Now for each of these groups, you will have a frequency, like maybe 5 passengers at during this time range, maybe 10 passengers between 8 a.m. to 9 a.m. and so on. So here again, you can have a grouped frequency distribution. Therefore, yes, we can use histogram to show this data. So whenever you are given any scenario which talks about data, the first thing that you need to analyze is whether that data can be divided into class intervals, whether that data can be represented in the form of groups. If you can, that means you can have a grouped frequency distribution, and for a grouped frequency distribution, you can have a histogram. Question number 2. The weekly wages of 30 workers in a factory are given below. Using tally marks, make the frequency table with intervals as 800 to 810, 810 to 820, and so on. Now, the first thing that we need to decide whenever we want to make a grouped frequency distribution table, the first thing that we have to decide is the class intervals. Now, 2 class intervals are being given. So basically, the first column would be groups, the second column would be tally marks, and the third column would be frequency. So for the first column, the question itself says that the groups or the class intervals should be something of this sort. Now, looking at these 2 class intervals, what do we see? We see that the upper limit of the first class interval is the lower limit of the second class interval, which shows that this is an exclusive class interval. So that means throughout it should be exclusive class interval. Also, what is the class size? Class size is 810 minus 800, that is class size is 10. So throughout we will have to maintain a class size of 10. Now for the second class interval, 820 is the upper limit. So for the third interval, 820 will be the lower limit. And what would be the upper limit? The upper limit should be something such that the size is 10. That means 820 plus 10, which is 830. What would be the fourth interval? It would be 830 plus 10, which is 840, and so on. Now, till where do we need to continue? Till that class interval which would accommodate the maximum value which is given here in this table. So we have 30 values here. So which is the maximum value that we have here? Let us try to find out the maximum value. 898. So do you have something greater than 898? No. So 898 is the maximum value. So let's see till where do we need to make class intervals so that we can accommodate 898. So when we take the last interval as 890 to 900, so 898 falls into this interval, and that's how we are able to accommodate all the data that is given, all the data of the 30 workers. Now for each of these class intervals, let us try to find out the frequency. So let's try to find out the values which are between 800 and 810. Now this is an exclusive class interval, so 810 would not be included in the first class interval. It would be included in the second class interval, right? Because in every class interval, the lower limit is included, but the upper limit is excluded. That is why it is called exclusive class interval. So for the first class interval, how many entries do we have? 1, 2, and 3. So there are 3 entries for the first interval. Similarly, let us try to find out the frequencies for different class intervals. And this is how we obtain the tally marks, just by counting the number of wages that fall in the respective class intervals, and from this we actually get the frequency. And this completes the grouped frequency distribution table. So the most important thing to decide here is the class interval, and to decide how the class intervals would be, first of all you will have to determine whether it is an inclusive or exclusive class interval. Then you will have to determine the class size. If you know these 2 things, you will be very correctly able to determine all the class intervals. Question number 3. The number of hours for which students of a particular class watched television during holidays is shown through the given graph. Answer the following. Okay, so here in the graph, what do you see? On the y-axis, you have the number of students, and on the x-axis, you see the number of hours they watch television. Now, looking at this graph, we will have to answer some of the questions. So, let us look at the first question. For how many hours did the maximum number of students watch TV? So, where do we have the number of hours? On the x-axis. So, just observe that duration, maybe 1 to 2 hours, 2 to 3 hours, 3 to 4 hours, in which duration maximum number of students have observed. So, you see in the first duration 4 students, second duration 8, 22, 32, 8, 6. So, where do you have maximum number of students? Here. So, which is this duration? This is nothing but 4 to 5 hours. So, the answer for this would be 4 to 5 hours. This is the duration during which maximum number of students watch TV. How many students watched TV for less than 4 hours? Now you see here, where do you have 4 hours? This is 4 hours. So how many students watched less than 4 hours? All those students who lie below 4. So how many students lie below 4? Here you have 4 students. Here you have 8 students. Here you have 22 students, because 4 students watch between 1 to 2 hours, which is less than 4 hours. 8 students watch between 2 to 3 hours, which is again less than 4 hours. Again, 22 students watch between 3 to 4 hours, which is again less than 4 hours. So, all in all, we can say that 4 plus 8 plus 22 students, which is 34 students watch TV for less than 4 hours. Question number 3. How many students spent more than 5 hours in watching TV? More than 5. So here we have 5. More than 5 would be this bar and this bar, because this is within 4 to 5. So this would be less than 5. So here more than 5 would include this 8 and this 6. So this would be 8 plus 6, which is equal to 14 students. So 14 students watch more than 5 hours TV.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.